So what we're going to talk about today is how to add and subtract radicals and radical expressions. So this is definitely one of the easier things to do with radicals because, as you're going to see here pretty soon, it's very similar to things we do all of the time. So first thing, and this part hopefully is going to sound maybe like a little familiar for things that we've been doing all year long. So the first thing we need to know is you can only combine like radicals. You can only combine like radicals. Now I say that hopefully that sounds kind of familiar because all year and last year in Algebra 1A, you guys learned that we can only combine like terms, right? You could combine a 2x and a 3x, but you could not combine a 2x and a 3y because the x and the y, those are not like terms. What we're going to find out is that like radicals are going to be along the similar lines here. So like radicals are going to have the same index. We talked about the index last week. The index is going to be the number on the outside of the radical. If there's not one there, remember it defaults to a 2 and it is a square root, which today, that's what we're going to see, is they're all going to be square roots. But just in case, they have to have the same index and they have to have the same radicand. Radicand, which is a word that we maybe haven't heard before, but it's the number or expression under the radical. So just like when we combine like terms, like I said, you know you could combine 2x and 3x, and when you take 2x plus 3x, you get 5x, but you could not combine 2x plus 3y, they'd have to stay 2x and 3y. What we're going to find out today is that if you have 2 square roots of 2 plus 3 square roots of 2, how they're both square roots of 2, you can combine those together, and we're going to find out that you can combine those the same way that you would if they were like terms. So to combine like radicals, just like combining like terms, you are going to add the coefficients. So the coefficients, remember, is the number in front of the variable, or in this case, the number in front of the radical, and you are going to keep the same radicand. So when you take 2x plus 3x and you get 5x, how it still stays an x, over here, when you take 2 square roots of 2 plus 3 square roots of 2, you would add 2 and 3, you would get 5 square roots of 2. Just like 2x plus 3x is 5x, this would be 5 square roots of 2. Okay, now, here's why these are going to be just a little bit different than adding and subtracting like terms. So adding and subtracting like terms, your 2x and 3x is just an x, that's all you can do. There's nothing really else you can do because it's just an x. If I look at this problem here, it says 2 square roots of 45 minus 2 square roots of 5. Just like 2x and 3x or 2x and 3y, it has to have the same x, it has to have the same y, it has to have that same ending part. Same thing with the radicals. Whatever's underneath the radical sign has to be the same. Has to be exactly the same. So if you look at this, I have the square root of 45, and I have the square root of 5. It's not the same. So technically, I can't combine these together. But what's different about radicals, I might be able to do something with these. Because that square root of 45, what can I do with the square root of 45? I can break it down. I can take it, right? Or if you like the perfect square factor method, I think overall we're liking the cake method more. If you like the perfect square factor method, go ahead and try that. But if you were to cake 45, cake the number under the radical, let's see what happens here. Out of 45, what could I divide out of 45? A 5. 45 divided by 5 is 9. Add another layer. What could I divide out of 9? 3. 9 divided by 3 is 3. Add another layer, divide out another 3, and there we go. So you can see here that I do have a pair of 3's, but guys, this is going to be super important. Remember the number on the outside, that 2, right? You have to take 2 times 3, which is 6, and what's left on the inside? The 5. So 6 square roots of 5 minus 2 square roots of 5. See now? They're both square roots of 5. Now I can combine these together. So you would take 6 minus 2, which is 4, and the square root of 5 stays the same. So 4 square roots of 5 would be your answer. Now looking at this one, I have 3 terms, but guys, it still works the same way. What you need to do, none of these are like radicals as it is, because I have the square root of 12, the square root of 3, square root of 20. None of those are the same. They would have to be the exact same number, the exact same expression. But if I look at 12, right, the number under the radical, I might be able to take 12. So out of 12, I could divide out of 2, we get 6. I could divide out another 2, I get 3. Divide out of 3, I get 1. So I do have a pair of 2's, but given I have it, there was already a negative 3 out front. So negative 3 times 2 would be negative 6. Square roots of, I was left with the 3. So negative 6 square roots of 3. Now with the plus 3 square roots of 3, remember you're caking the numbers under the radical. If you tried to cake a 3, it would be a very boring simple cake. There would be no pairs because 3 square roots of 3 is as simple as it gets. And then lastly, the 20. So we would need to try to cake 20. So out of 20, I can divide out of 2, I get 10. Divide out of 2, I get 5. Divide out of 5, I get 1. So I have a pair of 2's, but I already had a 3 out front there. So 3 times 2 would be 6 square roots of 5. Now remember, you can only combine like radicals. So I can only combine ones that have the same radicand. Do all of these have the same radicand? No. I do have negative 6 square roots of 3 and 3 square roots of 3, but this one is the square root of 5. That's not going to be able to be combined with the other ones. Now I can do negative 6 plus 3, which is negative 3 square roots of 3, and then you're just going to throw the plus 6 square roots of 5 on the end, because it cannot be combined with the other ones. Okay, let's get this glued into page 59. Okay, this is section 10.3, adding and subtracting radicals. Go ahead and get that glued in. Get your table of contents filled out. We don't have any homework to grade, so we'll go right into our examples. All right, so let's go ahead and try out a few of these. Okay, number one says 4 square roots of 5 plus 3 square roots of 5. So kind of the first thing we need to do, we need to decide if I can combine these together. If they have the same radical, which they're both square roots of 5, we can go ahead and combine these together. Now guys, remember this is just like taking 4x plus 3x. When you take 4x plus 3x, it's 7x. The x doesn't change, right? You just took 4x's and 3x's, you put them in the same place. It's the same thing here. You have 4 square roots of 5, and then you have 3 square roots of 5. You take those 2 piles of square roots of 5, you put them in the same place, and you just have 7 square roots of 5. Just like with like terms, the variable part doesn't change. The radical part does not change. You keep it the same. Okay, number 2, negative 4 square roots of 15 minus 6 square roots of 15. Okay, they're both square roots of 15, so I can combine these together. This time I'm going to subtract my coefficients because it's a subtraction problem. So negative 4 minus 6 would be negative 10. And that square root of 15 stays the square root of 15. Like with all radicals, we need to make sure our answer's in simplest form. So the only thing you could check to do here would be to simplify that square root of 15. But if you tried to cake 15, it's Divide out of 3, you get 5. Divide out of 5, you get 1. No pairs. So the square root of 15 would be in simplest form. Okay, number 3. Okay, this time we have 5 square roots of 3 minus the square root of 12. Now this time I have the square root of 3 and I have the square root of 12. Not the same thing. Right? They're not the same number, not the same expression. So I would need to make sure that these are both in simplest form before I jump to the conclusion that, oh, this is it, I can't do anything else. We need to make sure that both of these radicals are in simplest form. So if I look at the square root of 3, 3 is a prime number. You're not going to be able to simplify the square root of 3. You want to look at the square root of 12. Whether you do the cake method or the perfect square factor method, you are going to be able to break this down. What can I divide out of 12? 2, you get 6. What can you divide out of 6? 2, and you get, what can you divide out of 3? 3, and you get 1. So I have a pair of 2's. So that 5 square roots of 3 we said is going to stay the same. But that square root of 12 is going to turn into 2 square roots of 3. Notice now that I simplify the square root of 12. We have 5 square roots of 3 minus 2 square roots of 3. They're both now square roots of 3. So we can take 5 minus 2 and we get 3 square roots of 3. Right? That radical part stays the same. Okay, number 4. 4 square roots of 7 plus 2 square roots of 28. Now, as they are these like radicals? No. Do you think we're going to be able to simplify or break down 4 square roots of 7? 4 square roots of 7. Okay, 7's a prime number. That's not going to go anywhere. What about 28? So, yeah. If I were to take 28 or look for perfect square factors, we could divide out of 2, we get 14. Divide out another 2, we get 7. Divide out of 7, we get 1. Now it's going to be really, really important, guys. Yes, I have a pair of 2's. Always, always double check. There was already a 2 out there. So we have to take 2 times 2, and we get 4 square roots of 7. So I've got 4 square roots of 7 plus another 4 square roots of 7. When I combine these together, what do I get? 8 square roots of 7. Excellent. Excellent. Very good. Very good. Okay, let's try number 5. What do we do? 5 square roots of 32 minus 4 square roots of 18. Okay, not like radicals, because I got the square root of 32, I've got the square root of 18. So let's see if we can break these down. 32, we think we can maybe cake it. I'm going to probably give it like a solid maybe, right? So if you're not sure, just go ahead and cake it. If you can't cake it, or if nothing's going to pair up, it should be a pretty simple cake anyway. What can I divide out of 32? A 2, and I get 16. Divide out another 2, I get 8. Divide out another 2, I get 4. Divide out another 2, I get 2. Divide out another 2, I get 1. Yes, I can absolutely break that down. It's like a big, huge cake of 2's. So I have a pair of 2's, another pair of 2's. What else do I have on the outside? A 5. A 5, right? So it's going to be 5 times 2 times 2, which is going to be 20 square roots of 2. Now we need to go and we need to do the 18 as well. So out of 18, I could divide out of 2, we get 9. We could divide out of 3, and another 3. So we have a pair of 3's. What else do we have on the outside? Of negative 4. Negative 4 times 3 is negative 12 square roots of 2. Notice now they are both square roots of 2. So 20 minus 12 would be 8 square roots of 2. Okay, I want you guys to try this one. I want you guys to try 5 square roots of 8 plus 2 square roots of 72. You guys a couple minutes to try that one. 5 square roots of 8 plus 2 square roots of 72. All right, so if we go ahead and work this one out, can you break down the square root of 8? Yes, okay. If you were to break down the square root of 8, you divide out of 2, you get 4. Divide out of 2, you get 2. Divide out another 2, you get 1. So you have a pair of 2's. Is that it on the outside? No, you have 5 times 2. So 10 square roots of 2. And then with the 72, we could divide out of 2, we get 36. Divide out of 2, we get 18. Divide out of 2, we get 9. Divide out of 3, we get 3. Divide out of 3, we get 1. So I have a pair of 2's and I have a pair of 3's. So we're going to take 2 times 3 times another 2. So we should get 12 square roots of 2. So 10 square roots of 2 plus 12 square roots of 2, 22 square roots of 2. Okay, last one. All right, so let's say we have negative 10 square roots of 9 plus 3 square roots of 36 minus the square root of 50. Now, there's sometimes that if you're paying close attention and really looking out for things, your job can get a lot easier, because I think sometimes we see that number into the radical and we just jump straight to caking it, right? And if you cake 9, that's totally fine. But what is the square root of 9? 3. Don't cake it. If you know the square root of 9 is 3, you're just going to take negative 10 times 3, which is negative 30. Now, if you don't recognize that, that's fine, and in your cake you would get there anyway, but be on the lookout for these perfect squares. Because look, what's the square root of 36? 6. So you don't have to cake 36. Just say the square root of 36 is 6 and take 3 times 6, which is 18. Now when you get to the last one, the square root of 50, that's not a perfect square. So you are going to have to cake the 50. So divide out of 2, you get 25. Divide out of 5, and another 5, and away we go. So I have a pair of 5's. We're double checking. There is no number out front, but we want to get in the habit of checking anyway. So it's going to be negative 5 square roots of 2. Now the only thing I can combine here is going to be those two numbers there. Because just like if this was negative 30 plus 18 minus 5x, that minus 5x is the only x. This is the only square root of 2. It cannot be combined with the rest of these. So we would take negative 30 plus 18, which would be negative 12 minus 5 square roots of 2.